Okay, let's get started. Earth to class. Hello, hello. Let's get started. First, I'd like to just hear a brief minute or so update from each of the three projects as to how things are going. Let's start with Juan.
We are gathering our resources and our intelligence to put the video together.
Okay.
So there will be a video.
There's something significant about that. Sometimes the demo is more important than the product. Audience engagement. Someone from audience engagement will volunteer?
About the same.
Yes,
We have
Rachel.
filmed most of our video, and we're putting it together, editing it, polishing it.
And the side scroller.
Yeah, we're basically just finishing up having like a level to show in the demo. So
Hey, working code.
yeah.
That's good. I'll wait till the end of the lecture to talk about what's next. I'll take roll in. Excuse me, sorry. It's almost the end of the semester, isn't it? Everyone's kind of like, Aren't you grateful that I'm the type of teacher who ramps things down at the end of the semester? You know, less and less that you have to do. That also is very deliberate. I remember my own college days. I remember getting through finals week by the skin of my teeth. And frankly, you guys showed you know this stuff on the midterms. At this point, it's all great as far as I'm concerned. Come on in. So, the readings. Now, a number of you actually, first, number 7 was Pitfalls of Modern Software Engineering, which is a book that theoretically I started work on about 10 years ago, and have just never quite pushed through. I may yet. But the first 3 chapters were easy to revise because this comes from a book I did back in '95 that I've mentioned, Pitfalls of Object-Oriented Development, which I wrote after 5 years of a software startup using object technology. And you have to realize in the early 90s, object technology really was being touted as a silver bullet. You know, you can code 10 times faster, you know, this will happen, this will happen, this will happen. And we learned by our own sad experience just, you know, there are advantages certainly to object technology. There are advantages to anything that allows you to encapsulate complexity and abstract it. But they weren't multipliers in terms of whole digit multipliers. We weren't getting stuff done 10 times faster, or 5 times faster, or probably even 2 times faster. Maybe 2 times faster, but that's probably pushing it. Anyway, but the first 3 chapters all had to do with pitfalls that are really universal to adopting any new technology or methodology. And in the readings, I use that abbreviation TOM for technology or methodology. So when you have people saying, "Oh, just switch to Agile, you'll get everything done, and it'll work this much better," or you know, use functional programming, or you know, whatever the language du jour is. Code and go. That'll get everything done. There are inherent problems in adopting and relying upon any technology or methodology. Just to spare you, I won't go through all of these in detail. I'll probably call up a few. Theoretically, you've all read these, so I shouldn't have to go through them. Using the wrong developers, that's something we've talked about. Doesn't matter what kind of technology or methodology you have, it won't turn bad developers into good ones. The best you can hope for is being able to set up a development system that keeps poor or mediocre developers productive without doing damage. So you know, you're back to the fact that you can't, and this is a chronic problem. It's like, okay, we're going to do agile development. This is going to solve all our problems. And you assemble a team of not so great developers, it's not going to help. If you have a team of great developers, it's going to go wonderfully. But you could do waterfall with a team of great developers and do wonderfully. I hate to sound like a broken record, but trust me, this is what you're going to find. People do matter most. Using the wrong metrics, we already had one whole lecture on that. Lying to yourself and others. I remember writing this chapter. Oops, there we go. Self-delusion and group delusion are all too common in software development projects. It's kind of like, if we just buckle down and work a few nights and weekends, we can get this done, and, a miracle occurs here, and it doesn't matter how much testing we still have to do, or the fact that, we really haven't quite gotten the performance to the level it needs to be. When people are resisting, the symptoms here: irritation, anger, and disbelief when someone gives unpopular but honest appraisals of how things are going. That's a good canary in the coal mine indication. If you're trying to tell people, and this ties back to thermocline of truth, if you're trying to be honest and say, look, here are the problems that I see it, and people are telling you to shut up and code, there are some real serious problems here. That's just something to be aware of. And the problem, I've mentioned a number of times, being a consultant in Eric, I mentioned that's where they're doing network management for the second project that I was working on, where they're using a language no one had used, an obscure language, ASN.1, that no one would use. They're using a development environment running on IBM workstations that no one had. It was 1.0 release development environment and so on. And I wrote all these risks and was told to shut up and architect. And 6 weeks later, me being me, I wrote another memo and said, hey, look, 12 of the 13 risks identified haven't passed. And the project slipped and slipped again. They decided they didn't need me anymore as a consultant. And on my final day, I went out and had lunch with the division vice president. And he was looking for honest feedback. And I said, well, I know you and I have bumped head a few times. And I said, part of that's just par for the course. There are trade-offs. That's why you have separate architect from project manager. I said, but you should not have ignored the risks identified for the MCI project. I said, you end up to the customer looking either dishonest or incompetent. And actually the whole project, MCI canceled the whole project about 2 months after I left because the deadlines just kept slipping. They were so far behind, and it was actually one of those cases where each time it slipped by more than it had slipped the last time. So yeah, this is really, let's go back here. Not identifying and managing risks. A sign of a good organization is when they have a very active risk management system. I've been in as a consultant multiple times over about a 15-year period to Capital One. And they had lots of problems the first several times I was there. The last time I was there, which was about 5-6 years ago, I was actually very impressed. They had, up on Silverlight, which of course Microsoft is now end of life, they had a active risk management system where they would identify risks, they would categorize them as far as what type of risk it is, what portion. This is all for their customer-facing credit card website. What the likely impact is, what the probability. They reviewed this weekly, they prioritized working on them, and so on. An organization that is actively seeking to identify and manage risks is a good organization. Adopting a technology or methodology without well-defined objectives. This is sort of I address this from a couple different ways. Yeah, here, it's not uncommon for development groups to decide to adopt a new TOM, technology or methodology, because it is a good thing, yet they fail to establish what they expect to get out of it. Faster development, greater flexibility, and code reuse are nice phrases, but so are the flag, motherhood, and apple pie. In other words, the question you have to ask if it's being proposed to adopt a new technology or methodology is, what will be different from what we're doing right now? What's actually going to improve? What's going to change? And too often that's not something that's carefully thought. Misjudging relative costs. This is something that we've talked about. In fact, some of you gave some good answers to this on the midterm. It's going to take longer. If you're switching languages, and maybe 1 or 2 people on the team know it, but the other 4 or 5 don't, it's going to take longer. You're going to have some novice mistakes be made. It's going to take a while before the developers who are not familiar with the language are up to speed on the peculiarities of syntax, on desirable idioms, on the little gotchas that always exist there. Ditto for any library you're using, any engine you're using, any methodology you're using. The idea that this technology, I mean, let's take an engine. Yes, it saves you a tremendous amount of time to use an engine than to build one yourself. There's not much point in building your own 3D graphics engine, okay? There are ones out there you can use, and unless you really want to get into the market and do it and so on, then knock yourself out. But and this is the buy versus build issue. You buy the technology that you need simply to compete with everyone else, and then you build the stuff that distinguishes you, that puts you ahead. A lot of companies will waste time building the stuff they simply need to compete with everyone else. It's kind of like, oh no, we're going to do this. We don't, we have a better idea for 3D graphics engine. It's like, just find one and license it. Live with the problems, the defects, and focus on building a great game, or whatever you're building. And the challenges of this often show up. How many? I mean, because I track this sort of thing. Think of all the Kickstarter-esque game projects that have never materialized. Collected hundreds of thousands, in some cases millions of dollars, and have never come to pass. And you ask, why? How did this happen? Well, in many cases they failed to judge what the actual costs were going in and what they could actually solve. All right, there we go. Allowing new features to creep or pour in, we've talked about this ad infinitum. This is the requirements. Attempting too much, too fast, too soon. If you're adopting a new technology or management, do a pilot project. Do a pilot project. You want to make sure you know how it works, that you actually have success with it. You don't want to discover, I think the side scroller, didn't you discover some problems with the platform compatibility of the engine across 2 different platforms? You don't want to discover that mid-project, as you had to because of the nature of the class. You want to discover that by saying, okay, let's do a little sample cross-platform project with this engine, and let's figure out what works and what doesn't. And from there, you can start to make reasonable estimates as to what it's going to take to do a real project. Abandoning good software engineering practices. I don't see this as much anymore, but again, I'll tell you, remember, when I talked Inside Out last week, the whole reason for my original white paper was there were managers at Fannie Mae who said, well, we're doing object technology, we don't need to do QA. It's like, are you nuts? You need to do more QA. This is new technology, it's new languages, you don't know what you're doing, most of your developers have not been trained in this. You need more rigorous stuff. Beware when you hear someone say, we don't need to worry about that because we're using X. Because usually that doesn't hold up. Political pitfalls. Okay, not educating and listing management before the fact. Okay, there are actually several issues here. First is if you're pushing to adopt a new TOM, make sure you have properly explained to management what the costs and risks of that are. Don't say, oh yeah, we're going to do this. We've got this great new framework that we're using and this language that goes with it, and things are just going to go tickety-boo. The engineer's credo is under promise and over deliver. And too often what happens with these technologies is just the opposite. You overpromise and you underdeliver. That hurts your credibility. That hurts your reputation. Underestimating your resistance. We've talked about from a user perspective that how much users hate change. Programmers, a lot of programmers hate change too. If you're good with a particular language, if you're good with a particular IDE, with a particular set of APIs, with a particular engine, say, okay, we want to change this, and it's coming as a top-down decision. We're all going to code in Swift from now on. And you have programmers say, I don't like Swift. I want to stick with Java. I want to do this. Or you have a CTO who decides, by golly, we're all going to switch to functional programming. And you have a lot of developers who say, what? Are you nuts? Just second. Anyway, so don't and sometimes you have perfectly good reasons for adopting new technology, methodology, whatever. Don't underestimate the resistance you can get from fellow team members or the developers. Yeah.
That's along the same lines as I was thinking, because sometimes it's a good idea to accept these new methodologies and things, and you're at a good time and a good place to do it. But if you're doing it, partway in your development cycle, that can be a bad time.
Yep. And then the point here is not to not adopt it, it's don't underestimate the resistance you may face. So you need to make sure that your team is very involved in the decision making, they understand the reasons why. Don't oversell the technology or methodology. Again, this is under promise and over deliver. Politics of architecture. We've talked about that. Software architecture is fundamentally deciding the priorities in terms of capabilities of the system that's under development. And there's a lot of people you have to get in buy-in, because you may have management expecting one thing, you may have end users expecting something else, you may have the developers thinking they're going to build things a different way. And particularly as a chief software architect, you've got to sort of get everyone on the same page. Don't get religious about the technology or methodology, okay? I am both amused and tickled, as I think I mentioned a few weeks ago, to see that C is still one of the most popular and most widely used languages out there. I wouldn't have expected that 30 years ago, back when I was writing manuals for Turbo C. But there are reasons why, and a lot of it is, if you go back to Turing, to a large extent, the language doesn't necessarily matter that much. It can help, or it can get in the way, but people have done some pretty remarkable things with some pretty obscure languages and technologies. Getting on the feature release treadmill, this is technical debt, which I think someone said they just, it was Matthew who isn't here, who said at work he went and saw that written on a whiteboard as a to-do issue for the next release. The problem is sometimes success causes more problems than it solves, because you do the impossible and management now thinks that's the new baseline. And it's like, no, we have to go back and fix this and fix that and so on. Picking the wrong horse. Pages. We did a groundbreaking, design-oriented desktop publishing system for NextStep. And of course the irony there is NextStep eventually became Mac OS X. But we by the time, from the time we started to when we shipped, there just really wasn't much of a NextStep installed base out there. And we sold about as many copies as we could to the installed base, and we're trying desperately to move our technology over to Windows, and ran out of time. We'd already run through several $1 million of venture funding, and you know, my general line is it seemed like a good idea at the time. There were a lot of software companies, almost all of which are gone now, that bet on Next Step. Word perfect, action change. Anyway, so that's you need to realize there are going to be consequences to being advocate of a particular technology or methodology if it doesn't pan out. Oops, didn't change the headline there. These are conceptual pitfalls, not political pitfalls. Adopting a new technology, and these are all pretty much tied together, the first three. Adopting a new technology or methodology for the wrong reason. Which is, it's cool, it's leading edge. You get managers who say, yes, I read this article in Business Week about this new type of technology. I think we should switch all our programming over to this. And no, seriously, again, this was so true in the 90s. Object technology was being so touted. You were getting organizations that were switching to object technology for a management mandate, even though they didn't have expertise in-house. Thinking a new technology or methodology comes for free. It doesn't. There's always a learning curve. Sometimes it's a pretty painful learning curve. Thinking will solve all your problems. And I like what I did here. Here's my, let's see, the list here. Here are all the various tasks, more or less, involved in creating a new program. If you go through these, what you'll find is that the new technology or methodology being touted only affects a handful, if that many. Most of the tasks are human-oriented, or they involve processes or technologies which are unrelated to the technology or methodology in question. And so part of the realization is whatever you're adopting is only going to affect a small part of the life cycle. It's not going to solve all your problems. Confusing buzzwords with concepts. Agile. Oh, we're doing everything agile. Well, you know, does agile mean you have stand-up meetings in the morning, you've got a whiteboard where you have tasks, and you're doing something called sprints? Or does agile mean you actually have people who have repeatedly used agile methodologies to bring software projects in successfully? Ditto, tools with principles. Saying, well, you know, we're we're coding in a Java. Of course it's object-oriented. And you go and look at the code itself, and you've got, like, you know, a main procedure that's 20 pages long. Things like that happen, trust me, they do. And you get scary things. Luke Holman, and I, in passing, will recommend his book, it's not psychology, it's sociology. Okay, I'll have to look it up. I'll mention it next week. Talked about interviewing an entry-level developer for a software company. And this person had gotten a BS in computer science, 4-year degree, and had never coded in anything but Java. And he was absolutely terrified. It's like, how can you understand programming if you've only ever programmed in one language? Confusing training with skill. You know, sending me to, let's pick Go. Send me to a 5-day class on programming in Go doesn't make me a skilled Go programmer. Now, I'll have some advantages. I've been coding for 40 plus years, and so as I'm learning, it's kind of like, oh yeah, this fits in here, this fits in here. I mean, I can actually pick up new languages relatively easily, simply because I have used so many over the years. Nevertheless, I'm not the person you'd want to use on a mission critical project that required great expertise and go. A lot of organizations will send people out for a seminar for a week or two and think, okay, now they've got it. You know, we'll send our team out to a week-long seminar on Agile, and then we're going to use Agile for a mission critical project that has to be done in record time. Doesn't work that way. Confusing prototypes to finished products, we've mentioned that a number of times in here. For a long time, I had the idea, and I can't remember if I mentioned this, if I'm repeating myself, my apologies, but hey, I'm the teacher. I wanted to build a quarter scale PC. Little tiny screen, little tiny keyboard, all fully functional. And have teams, when they go to show their prototypes, do it on the quarter scale PC. And then say it's going to take us 6 months to make it work on a big system here. And I think there are managers who'd say, oh yeah, I understand that. The problem is that, you know, you have such great prototyping tools, you can make something that looks really nice really quickly, and they're like, oh, why isn't this done? Why aren't we shipping? Confusing approach with results. The fact that you are, say, yes, you know, we're doing pair programming. Yes, we're, you know, building all the tests and so on. Yes, therefore, because we're doing that, everything's going to be fine. The results are the results. Your approach may help you, it may hinder you, but it's going to boil down to the quality of the developers and the tools that they're given. Asking the wrong questions. This is especially true. I'm out of industry enough to know how much this is, but you have the why isn't someone coding yet? I think Agile was invented in part just to shut up that question from management. Oh, we did. We are coding now. Oh, okay, that's fine. But if you have a more waterfallish approach, it's kind of like, why isn't someone coding it? Well, because we're still trying to figure out what to build. We're still gathering requirements. But why aren't you coding it? Because we don't have anything to code to. But I want to see something running. And then you get, you know, you get prototypes that are sort of like, here, keep management amused with this while they do actual work. And of course, the second question is, when will the program ship? As I say, these are not bad questions, but if these are the only two questions being asked, they will distort the whole software development process. Let's see here. That's it. Okay, number 8. Boy, you guys can get out of here early today. Patterns in IT system. Litigation systems failure. This is the white paper I did at PricewaterhouseCoopers. We gathered, I actually had a staff, had them comb through to identify lawsuits that were like 2 or 3 party lawsuits over failed IT projects and get what information they could do. These are usually summaries of the litigation that were published in various law journals and so on. And then we would try to get as much information about the lawsuit outside of that original source as we could. And I had like a 3-foot shelf of documents that I read through on all these cases, built up a database, and so on and so forth, and found that, as I said, most fell into 1 or 2 fact patterns. We've talked about a lot of these already, okay? And I gave them cutesy names because that's the sort of thing you do when you're writing a white paper. Faulty towers is the, you know, gets installed, goes into production, doesn't work properly, they come back and they try to make it work, doesn't work properly, and the cycle just sort of churns until, since these are all lawsuits, the conclusion here is at some point the customer says, that's enough, I'm suing. Irrational exuberance, okay? Old joke, what's the difference between a used car salesman and a software salesman? The used car salesman knows how to drive, knows how to drive and knows that he's lying. The problem with software is that the people selling, the vendors, the salespeople out there selling software, usually don't know how to use the product that well, certainly not in all its complexities, and as a result, often don't know that they're lying. It's kind of like, oh yeah, we can do that. And then they go back and the engineers scream at them saying, oh, we can't do that. We're not going to be able to do that for a long time. Sometimes you have it on the customer side as well, which is the idea, we're going to bring we're going to do an SAP installation, some form of enterprise resource, and we're going to cut 20% of our workforce as a result and save these, $20 million a year. And then the SAP project turns out to be late, and it's very interesting if you study statistics on large-scale failed projects. For a lot of people, the failure is, well, it was seriously late or seriously over budget. But for a large chunk, the failure is we didn't get what we thought we were going to get out of it. We spent $50 million on this ERP installation, and guess what? Our headcount's the same. We don't see we don't see the benefit that we were hoping for. Three's a crowd. I've actually testified in a couple of these cases where you have three parties involved. So it can be the customer, a vendor, and a subcontractor, or a customer, an implementer. A lot of the SAP projects you have, well, the one I testified to in June. You had the customer, you had a firm that was the implementer of SAP, and then you had the SAP company itself, the actual software producer. Some cases they managed to steer clear. In this case, SAP did pretty much stay clear. They weren't a party to the suit. In other cases, you get sort of this finger pointing. The customer sues the implementer, and the implementer says, well, it's the vendor's fault. Or they sue the vendor, and the vendor says, oh, it's the implementer's fault. Never-ending story. This, of course, we've talked about many, many times here. This is this is the most dominant and the most classic pattern, which is 3 weeks before shipping, it slips 6 months. It isn't always 3 weeks, it isn't always 6 months, but boy, the pattern is there. And once that's happened a couple times, you can be pretty sure the system's never going to successfully go into production. There are plenty of cases where, they get close to shipping and say, we're going to have to, delay a few months, and they finish it and they go into production, and it's the end of the story. When there are serious underlying problems is when you see this, slip, work, slip, work, slip, work pattern over and over again. Unplanned obsolescence. Vendor withdrawal support. What was the graph I brought up about the number of systems out there still running Windows XP? 7 or 8% of all desktops out there still running XP. That's we've had, several versions since then. So you'll have the vendor will withdraw support, or you start to have incompatibilities. Now, for a lot of those places that still have, say, Windows XP running, they have it running precisely because they've got other software which only works on XP. In many cases, they lack the source code to go through and rewrite the software to work under 7 or 10, or the company just doesn't want to spend money. I find it fascinating. I don't know how many of you notice this. You go into some place, a store or a hospital or something like that, and something happens to the computer, and you see the Windows XP or the Windows 7, screen up there saying, please reboot or whatever. Unintended consequences. Apple's been dealing with a lot of these lately. You release a patch and you break something else. The fact that you can log in just using root with no password was staggering. And what was even funnier was someone dug up a end user suggestion on an Apple support forum from like 2 weeks before this became news, saying someone was locked out of their system. Oh yeah, I said, actually if you type root no password, try that a couple times, it may let you in. So someone was actually posting it on a forum as a way around if you had forgotten or someone had changed the password or whatever, a way to get in. Sometimes this can cause serious enough problems that it ends up in lawsuits. So, there are more details, but I assume you've done the reading. Okay, we're almost done with the class, folks. Video presentations next week. I'd like each, along with your video presentation, before or after. Probably after, so we don't all lose interest. Just what your lessons learned were. I just like, brief, here's how we started out. This is what went well. This is what didn't go according to plan. Here's what we do differently. That's what I'm very interested in hearing. What you do differently, knowing what you know now, because that's the most valuable information you can gain doing software projects. I'm going to do different next time. There were some weird problems going on with the billable hours. I had several people with emails. Congratulations, you all got full credit for billable hours 3 through 7, because it was easier for me just to set them all to the default, rather than try to figure out what the problem was or so on. So there you go. If this class wasn't easy enough as it was, you just got that. Everything else needs to be done by next class period. I think there's probably the last billable hours due by Saturday. I've got all the lectures and all the videos out up through last week, and I'll get these ones out for those who want to and need to do attendance makeup, or who have any extra credit reading want to do. You've got till the last day of classes, which is the 13th. Yeah.
Just so you know, the default was 1 out of 8 points. So.
Now the class average is a C.
Oh, hey, cool.
Actually a D.
In that case, I'll go back and actually I may sit and do it while we're sitting. I clearly did not look at that carefully. Let's see. But other than that, we're pretty much done. I have had one request for a final exam, so if anyone else wants to do a final exam, let me know as well. It'll be electronic. It'll be through Learning Suite. And I'll just set up a time block. It won't be here in class. You'll just log on from wherever you're at. And do, again, open book, open note, so on and so forth. Yeah?
Will you have final grades posted for the final? So like if we wanted to compare.
Well, if I get these corrected, then you should have, your grade should be out there. I'll go in. Let's see, I've had a few corrections of attendance from people who have come back to me and said, yes, I did this. If anyone else has it, that's fine. Otherwise, I'll basically do attendance for today. That's the question. I'll figure out what I did wrong with the billable hours thing. I have to look at that. Wonder what. Oh, I'll bet you I know what it did. I did one thinking because it counts for, each one I think counts for 1 point of your overall grade. But it figures that base, maybe it counts 7. I'll look at it. I think it is 1 point. I put 1 in there, but I think it's, oh, I'll get it straight.
If you just make it out of 8,
I'm easy.
make it out of 1, it'll work.
Huh?
Just change it out of 8 to out of 1. Won't that work?
I'll figure out.
Alright.
I'll figure out what the problem is. That's it. Any other questions? If not, you guys are free to go. And we'll see you here next week.